So our next conic section is a hyperbola. A hyperbola is the set of all points in a plane. The difference of whose distances from two fixed points is constant. These two fixed points are called the foci. The line through the foci intersects the hyperbola at 2 points called the vertices. The line segment that joins the vertices is the transverse axis. And the midpoint of the transverse axis is the center of the hyperbola. All right, so a hyperbola, it looks like two parabolas going in opposite directions. They're not exactly parabolas, and in fact, we call them branches and not hyperbolas. I'm sorry, and not parabolas, but you know, it kind of looks like you got these two parabolas. All right, so I know this is a little bit blurry, so sorry about that. We have our center right in the middle, and then we have our vertices, which are the spot that the transverse axis is the line going through the centers that intersects these two branches. The vertices, that's where the branch is hitting our transverse axis, and then the focus is this fixed point, but the foci are always inside the branches. What else is it? Notice that the center is midway between the vertices and midway between the foci as well. So here's our equation for hyperbola. It looks exactly like the ellipse formula, except there is a minus sign in between. So because there's a minus sign in between, and we know that subtraction is not commutative, we have to be a little bit more conscious about which variables first. Like with an ellipse, we always put the x squared first and the y squared second, and it doesn't make a difference. And the reason it doesn't make a difference is because it's addition and it's commutative. But here, a squared is always under the first term. So whichever variable is first, x or y, that tells us the direction that the hyperbola is going to open. So if the x is first and has, you know, the plus in front of it, it's going to be a horizontal hyperbola, meaning that it's going to open side to side. But if the y is first, then we're going to have a vertical hyperbola, and it's going to open up and down. The center is HK, but you got to be super careful here because the H is always with the X and the K is always with the Y. So you can't just go in order and say, oh, my center is this number and then this number. You really got to be conscious and pay attention to H being with X and K being with Y. There's plenty of times I've done it backwards and had my center off because the Y was first. The vertices are A units away from the center, and the foci are C units away from the center, but this time our formula for C is that C squared is equal to A squared plus B squared. So this is where I mentioned this when we talked about ellipses a week ago, that the sign in your formula for C is always opposite the sign in your like standard form equation. So ellipses had a plus sign and the C squared formula had a minus in it. And here our hyperbola has a minus sign in it, so our C squared formula has a plus sign in it. Any questions so far? So to graph a hyperbola, we're going to start by locating the center. Then we're kind of going to get started like we do with the ellipse, where I'm going to go, you know, up and down and side to side, A and B units. But instead of then drawing an ellipse, once you get those 4 points, we're actually going to draw a rectangle. So we're going to use dash line. I typically use dash lines just because the rectangle is not actually part of the graph. So kind of like we do with asymptotes, where we use dash lines to indicate a guideline rather than an actual part of the graph. So we're going to use dash lines to draw the rectangles centered around the center with sides of plus or minus A and B. Then we're going to draw the diagonals of this rectangle and extend them to obtain asymptotes. we'll draw the two branches of the hyperbola starting at each vertex and approaching the asymptotes. It's easier than it sounds. So we're going to graph, we'll state the center, the vertices, the foci, and the asymptotes of the equation. I think the hardest part here is writing the equations of the asymptotes, especially when our center moves off of the origin. Okay, so let's take a look here. We have x squared over 1 minus y squared over 4 equal to 1. Since the x, well, I see the minus sign, so that tells me hyperbola. Then I see that the x is first, so that tells me that this is going to be a horizontal hyperbola. We want to identify the center. Since there are no parentheses, we know that the center is at the origin. And now, just like the ellipse, I'm going to take the square root of each number under x and y and then go that many units in either the x or the y direction. So square root of 1 is 1. So I'm going to go 1 in either of the x directions from my center, and then the square root of 4 is 2. So I'm going to go 2 in the y direction from my center. With an ellipse, we connected these 4 points and made, an ellipse. But what we're going to do with these 4 points is make a rectangle. Any questions so far? Okay, so now we want to draw in the asymptotes, and all we're going to do is extend the diagonals of this rectangle. So I usually start at the center and then go out. Once we have our rectangle and our asymptotes, we can go ahead and draw in the hyperbola. We know that it's open horizontally. So we're going to start by hitting the point on the rectangle, and then it just approaches the asymptotes. And we're going to do the exact same thing on the other side. And there it is. Questions on drawing the hyperbola? Well, now we'll go back and answer all the questions. So we want to identify the vertices. The vertices it's basically just wherever your branches hit your rectangle. So that's going to be -1, 0, and 1, 0. We want to identify our foci. Our foci are c units away, where c squared is equal to a squared plus b squared. So c squared is going to be 1 plus 4, which makes c the square root of 5. Our foci are always inside the branches, here and here somewhere. So I know I'm going to have to be adding to the x coordinate of the center since I'm opening horizontally. So our foci are going to be plus or minus square root of 5, 0. something that can also help you remember your equation for C, whether it's, the plus or the minus, not to confuse it with the ellipse, is remember if we were doing this and we were drawing in an ellipse, here would be our ellipse, and the foci are always inside the ellipse. So if you tried to, and the branches of the hyperbola, you notice, are outside the ellipse, so the foci have to be inside the branches. So just kind of thinking of what your shape is and where the foci are located, if you use the wrong formula, you're going to end up with foci not where they're supposed to be. Either your foci for the hyperbola aren't going to be inside the branches, they're going to be inside the box instead, or for the ellipse, if you use the wrong one, your foci won't be inside your oval. Last thing we need to do is identify the asymptotes. So we have two of them, starting with this one. We know in order to write the equation of a line, we have to have the slope of the line and one point on the line. I typically use the center as my point. And then to get the slope, just use the center and like the corner of your box. So from the center to the corner, I've gone up 2 and to the right 1. So that tells me I have a slope of +2. So I'm writing the equation of a line with a slope of +2 passing through the point 0, 0. And I mean, I guess you'd go through the whole process of writing the equation of a line, but hopefully you guys can see that this is a y-intercept of 0, so I can just plug it right into y equals mx plus b and simply get y equals 2x. And then asymptote number 2, its slope is always just the opposite of the other asymptote. So since we had a slope of +2, we know that this is a slope of -2, and it's passing through the point 0, 0 as well. So our second asymptote is y equals -2x. And that's our hyperbola. Any questions? I know in the take-home quiz for all these conic sections, I also asked for domain and range. We'll see what the next test is like, if that's an option for me to ask on my math lab or not. But heads up on the take-home quiz, a lot of times people miss it. In our next example, we want to write the equation of a hyperbola with foci of 0, -6, and 0, 6, with vertices of 0, -2, and 0, 2. Because it makes a difference whether the x or the y is first with a hyperbola when writing our equation, I'll usually take the information that they've given us and kind of graph it so that I can determine whether it's a horizontal or a vertical hyperbola. So the foci are at 0, -6, and 0, 6, while our vertices are at 0, -2, and -2. Oh, the foci are inside the branches of our hyperbola, and the vertices are the point where our branches hit the rectangle. So that tells me that this has to be shaped like this. It's opening in the y direction, so that tells me that y has to be first. We're using y minus k. See, notice how it's k with y and not the h. Minus x minus h squared. The center is always equidistant, like midpoint between the vertices or the foci. So where's the center going to be for us? At the origin. So I know my numerators simplify to y squared and x squared. Our foci are c units away from our center, so we see that our c value is 6. And we know that our vertices are a units away from the center. So we know that a is equal to 2. So I can go ahead and put my 2 squared underneath the y and get 4, but now we're going to have to use our formula for c to get our b value. C squared is a squared plus b squared. So 36 is equal to 4 plus b squared. So b squared is going to have to be 32. And that's what goes under our x squared. And we have our equation. Questions at all? All right, so let's do some where we're not exactly in standard form to start. This next example is not in standard form because we're not equal to 1. So the first thing we'll do is divide everything by 144. This gives us y squared over 9 minus x squared over 16 equal to 1. We want to look to see which variable is first, because that tells us which direction we're going to be opening in. Since the y is first, that tells us that this is going to be a vertical hyperbola. Our center, since I don't see any parentheses, is going to be the origin again. And now we want to create our rectangle. We're taking the square root of 9 to get 3. So I'm going to go 3 in the y directions. And then the square root of 16 is 4. So I'm going to go 4 in the x directions for my center. And then I'm going to create a rectangle with these 4 points. Once we have our rectangle, we want to extend the diagonals of this rectangle. Once we have our asymptotes, we can draw in our branches. We established that this was going to be a vertical hyperbola. So I'm going to be opening up and down, making sure that I hit my vertex. for each branch. And there we go, hyperbola in red. Questions on graphing? Yeah, I like these conics. I think they're pretty straightforward. All right, let's answer the rest of our questions. We want our vertices. What are our vertices?
Uh, 4, 0, and 0, and -4, 0. Wait, now 0, 4, and 0, -4.
All right, count one more time.
Wait, what? 0, 4, 0, -4?
Isn't it 3, right? So our vertices have to be where our branches are hitting our rectangle.
It's too early, man.
All right, so if we count them here and here, that's only 3 units.
Yeah, sorry.
That's all right. Okay, and then our foci are going to be c units away from our center, where c squared is equal to a squared plus b squared. So c squared is 9 plus 16. We get c to be 5. And recall that our foci are always inside the branches. So they're going to have to be like here and here. And we're going 5 units from our center. This is vertical, so we're adding to the vertical component of our center. Our foci are going to be at 0, 5, and 0, -5. I'm sure my math lab won't let you do the plus or minus. Make sure you list them out separate. I'm fine with the plus or minus. And then we need to do the asymptotes. Again, these won't be bad since our center is at the origin. So taking a look at this first asymptote, what's its slope going to be?
Uh, 3/4.
3/4, we're just counting from our center to the corner of our rectangle. So slope of positive 3/4 and passing through the point 0, 0, we can just plug it right into y equals mx plus b and get y equals 3/4 x. And then our second asymptote, remember that our second slope is always just the opposite of the first, so it's going to be -3/4. And we're passing again through the point 0, 0. Y equals -3/4 x. Questions, anybody?
When would we have B, or we are not going to have B at all in this kind of problems?
Say that again.
Like the formula for asymptote is y equals ax plus b. Would we ever like have B in this kind of problem for asymptote?
I guess I still don't understand your question. I mean, there's our B value right there is 16, is our B squared.
Like for asymptote, like sometimes we can.
Asymptote?
Yeah.
I mean, we're just trying to write the equation of this line. So we're just using stuff that we've learned like a lot of years ago. So here's a point and here's a point. Now, I did see, I was making an answer key for my virtual class, and the answers were not integers. So their slope ended up being like square root of 3/3. So that can happen. I don't know if that's your question.
Okay.
But we're
Thank
just
you.
trying to calculate the slope between these 2 points. So I mean, I could have written down the ordered pairs, calculated the slope, but would rather do less work and just count boxes to get the slope. And then, I don't know. Have I answered your question at all?
Yeah, thank you.
Okay. All right, so let's get off the origin, and maybe this for our center, maybe this will answer your question even better. So I see the minus sign, so that tells me hyperbola, tells me I need to pay attention to which variable is first. Y is first, so we know that this is going to open in the Y directions. This time our center is not the origin. What is the center going to be? Be careful, remembering that H is always with X and K is always with Y.
-1, 2.
-1, 2 is going to be our center. Well, that's nice. Okay, so plotting our center, which was -1, 2. And now we want to construct our rectangle. We're going to take the square root of 36, that's 6. So from my center, I'm going 6 in either Y direction. And then the square root of 49 is 7. So from my center, I'm going 7 in each X direction. And now we're going to make a big rectangle. We'll extend the diagonals of this rectangle to get our asymptotes. And then we'll draw in our branches. We already said it was going to be vertical, so I know it's opening up and down, and I'm going to start at the point on my rectangle, my vertex, and then tend towards my asymptotes. And our hyperbola is in red. Questions at all? Okay, let's answer all our questions. So our vertices, what are they going to be?
-1, 8 and -1, 4.
-1, -4. Great. Our foci are going to be C units away from our center inside our branches. So somewhere here and here. So let's find that C value, where C squared is equal to A squared plus B squared. We get C to be square root of 85. All right, well, I know where they need to be. from my center, since this is opening vertically, we want to add that square root of 85 to the vertical component of our center, the y value. And our y value is 2, so our foci are -1, 2, plus or minus the square root of 85. Questions on any of that so far? All right, on to our asymptotes. And I feel like this is the hardest part of the hyperbolas when we're off the center. So looking at our first asymptote, we want to figure out what the slope is. So what's the slope of this?
Six sevenths.
6/7. Now, I mean, you may have started to notice a pattern that our asymptote slope is always b. Wait, that's not right. Never mind. I don't want to say that. Because A and B switch for us here. So never mind. I don't want to say that. Just count the box. All right. So slope of 6/7, and then we have to choose a point that is passing through. And like I said, I always pick the center. But now we have to do the full process of writing equation of a line. You can use point slope form or slope intercept form. I prefer point slope. And for our first one, we get y equals 6/7 x plus 20/7. And I usually always do a quick check to make sure after I've written my equation that it looks like my y-intercept is in the right spot. I know my asymptote line isn't perfect, but 20/7 is just shy of 3. So I kind of just then go in and look and see, okay, does it look like in my drawing that my y-intercept is about 3? And it does, so it makes me feel extra confident about my equation. And now we want to do the other one. It's still true, even when we're off the center, that the slope of that second asymptote is just the opposite the first. Our slope is -6/7, and we're passing through our center, -1, 2. We get y equals -6/7 plus 8/7. And I do the same thing again with that y-intercept just to make sure that I didn't make some kind of mistake. So that's just a little bit over 1. And if I take a look at my asymptote, it looks like that y-intercept is happening right about 1. So I feel good with my equation. Questions? Anna, did that answer your question better once we did one off the origin? Or?
Yeah, that's like that's what I was asking. Is there can be like that other number like 8/7? That's what I was asking.
Gotcha.
That's the case when it happens.
Oh, I
okay.
see what you're right. Okay, great. Anybody else? And I guess I should have mentioned this when we were doing our like the intro here about when am I ever going to see a hyperbola in life? Really, I feel like the main real life example of when we see a hyperbola is like a nuclear cooling tower that's created in a hyperbolic shape to it. So like when we get to the end of this, I don't have application problems for it because well, there aren't a ton. All right, but this is the last one for today. Gross, right? We just have to complete the square here. I was thinking though, I haven't really looked at what the MyMathLab questions are for the next test, but I was thinking that I might just put equations and have it like tell me what type of conic section it is just based off of the equation. So if I can find problems like that, I'm definitely going to put it on the next test without having to do all the work. Like I can just look at this and know that it's a hyperbola. And the way that I can just look at this and know that it's a hyperbola is I see that both x and y are squared, and they have opposite signs, that the x squared has a positive coefficient and the y squared has a negative coefficient. So if one's positive and one's negative, dead giveaway that it's a hyperbola. If x and y are both squared, but they're both positive or both negative, then it's an ellipse. I know when we did ellipses, the leading coefficient for both, x squared and y squared was always just positive. But if they're both negative, that's an ellipse too, because you just divide through by a negative and it switches them to both positive. On Wednesday, we're going to do parabolas, and a parabola, only one of the variable is squared. So that's how you know, just based off of a general form equation, what conic section it is. All right, so let's do this one. This is going to involve completing the square, and I think it's definitely the most challenging of the completing the squares. And it's just that minus sign. So let's get it organized. Let's get our x's together, our y's together, and our constant to the other side. Now, whichever one is positive, put first. So like if this had been the y squared was the one that was positive, then put it first. Or even if like they wrote it this way, put the positive one first. All right, so we're going to complete the square very similarly to how we did with the ellipse. So in the first two, we want to factor out just whatever the leading coefficient is, because we know that our leading coefficient has to be 1 in order to complete the square. Now it's the second one, the negative one, that I think is a little tricky. I need that to be 1y squared. So we're actually factoring out a negative 9. And when we factor out a negative, it's going to switch that 54 to be negative 6. So just be careful with that. It's easy to miss that negative. And now we can complete the square. So starting with the x, negative 4 divided by 2 squared is 4. So we're going to add in our 4. What do we end up adding to the other side?
16.
16. Remember, you got to distribute that. And we'll add our 16. And now for the y, negative 6 divided by 2 squared is negative 3 squared, which is 9. So we'll add in our 9. What are we adding to the other side?
81.
But careful here. Look what we're distributing.
Minus 81.
Negative 9. So we're actually going to be adding a negative, or of course, I'm just going to write subtracting 81. That's what I think is the tricky part. It's just that negative, making sure that when you factor out that negative, that you switch, this term sign, and then when you go to add it to the other side, making sure that you're distributing that negative back in. So this is going to turn into 4 times x minus 2 quantity squared minus 9 times y minus 3 quantity squared equals 36. And now we're going to transform it into standard form by dividing everything by 36. X minus 2 squared over 9 minus y minus 3 squared over 4 is equal to 1. Questions on transforming it from general form into standard form? All right, is this one going to be opening up and down or side to side?
Side to side.
X is first, so it's going to be opening side to side. You know what? I'm just going to pause the video. Why don't you guys draw this in? We'll come back to all the questions together if you like. But why don't you guys get this one graphed? So how's our hyperbola look? Anybody get anything different than me? Have any questions? All right, well, let's answer all our questions then. Where are the vertices located? Right.
Negative 1, 3, and then 5, 3.
Great. And then our foci are going to be c units away from our center, where c squared is equal to a squared plus b squared. So we get c to be the square root of 13. Where does that put our foci then? I know they're going to be inside my branches here somewhere. Foci, anybody?
Is that 2 plus or minus the square root of 13 and 3?
Perfect. And then on to our asymptotes. All right, so the slope of our first asymptote counting from my center to the corner of my box, up to over 3. So that's a positive 2/3. And then we're passing through our center, which was the point 23. We get y equals 2/3 x plus 5/3. And then for our second asymptote, our slope is just the opposite, -2/3, and we're going to use the center again. We get y to be equal to -2/3 plus 13/3. Questions at all on hyperbolas? All right.
How did you get the parabolas to be on the sides for this one?
Because the x was the positive one, the x was first. So it's opening in the x direction. And if you-
Okay, thank you.
So I think the very first one and this last one, it was opening sideways because the x were first, and then the ones in the middle, the y was the positive one. So we were opening in the y direction. Anybody else? Anything on hyperbolas? Yeah, sorry with the chat. I'm not totally set up for that. I need multiple screens. If we go to this more permanently, I got to get a better setup with multiple screens so I can see the chat and all this at the same time.
Hook your tablet up to your TV and then you can have dual monitors.
Yeah. Okay. Well, right now I'm like shoved in the corner of my dining room. I had to mute the screen because I needed to plug my cord in. I had to move my dining room table closer to the outlet. Like, yeah, someday. Not today. All right, I'm gonna move on to the next one. Let's introduce the parabolas. So I know you're like, well, I already know everything about parabolas because I've been graphing parabolas. That's not true. You don't know everything. Yes, you have been graphing parabolas, but we're gonna be turning them sideways, and actually how we're gonna go about finding everything is totally different than what you've learned before. Now, that doesn't mean that what you haven't learned before isn't applicable. Sure, when it's in that form, when it looks like, you know, a traditional quadratic that we're used to seeing, fine. Use graph by transformation. Use the fact that the x-coordinate of the vertex is -b/2a, but sometimes that's just not the format that we're in, or sometimes they're asking us other questions, so we're learning an additional way to approach the parabola. Plus, this handles sideways parabolas as well. So this method's kind of nice because this takes care of both types of parabolas, the ones that open vertically and the ones that open horizontally. However, it does not tell you anything about x or y intercepts. So if you're asked any question about x or y intercepts, you still have to approach it the same way you always have. All right. So a parabola is a set of all points in a plane that are equidistant from a fixed line called the directrix and a fixed point called the focus, and that focus is not on the line. So it's just saying that this point right here is equidistant from here and here. This point right here is equidistant from here and here. Those two distances are the same over and over again. So that's how they define a parabola in terms of a conic. Please note that the directrix is always behind the parabola and the focus is always inside the parabola. The line passing through the focus and perpendicular to the directrix is called the axis of symmetry, but we know that that axis of symmetry also goes right through the vertex. So the point where our axis of symmetry intersects the parabola is the vertex. Please note that the vertex is halfway between the directrix and the focus. So how to determine how wide the parabola is? It's a line called the latus rectum. This is the line segment that passes through the focus. It's parallel to the directrix, and its endpoint is on the parabola. The entire length of this latus rectum is the absolute value of 4p. I mean, they have to say the absolute value because we're talking about a distance, so we don't want to talk about it in terms of a negative number. But what I think of when I'm doing this is I'm like, all right, I go to the focus, and then I'm going to go 2p up, and then 2p down from the focus, and that gives me my points that are on the parabola, tells me how wide it is, and then I just connect it from the vertex to those 2 points. And that's true whether your parabola is facing sideways or up and down. So how do we determine whether it's opening up and down or left and right? It depends on what variable is being squared. So far, you've only graphed parabolas that opened either up or down. And which variable was squared on all those? The x. So if x is squared, it's going to open up or down just like it always has. If the y is the variable squared, it opens left or right. I think of it that way because, you know, with the other two conics, if the big number is under the x, we always say, oh, it opens it's big in the x direction. Or with hyperbolas, if the x is first, it opens in the x direction. Well, that's not necessarily true here. It's actually the opposite. Whichever one's squared, it's opening in the opposite direction. So rather than thinking that, I just go back to, hey, I've been graphing x squareds a long time, and they always open up and down. So if y squared, it's got to be the other one. The vertex of the parabola is HK, and again, heads up, be sure you're paying attention, just like with the hyperbola, that the H is always with X and the K is always with the Y. The entire length of the latus rectum is 4p. The directrix and focus are p units away from the vertex. So with the parabola, we don't have that C that we use to identify the foci. We're going to be using the P. And the P is right here in our equation. So it's really important that we get these parabolas into the standard form so that we can identify the P. Any questions so far? If your P is positive, then the parabola is going to open in the positive corresponding direction. So if it's opening either up or down, the positive is going to be up. If it's opening left or right, the positive is going to be to the right. And then similarly, if the P is negative, then the parabola opens in the negative corresponding direction. So if it's up or down, negative P, we're opening down, left or right, negative P, we're going to the left. Questions at all before we do one? All right, let's graph. We'll state the vertex, focus, and directrix. Well, first off, is this going to open up or down? Look at the variable that's being squared. It's y is being squared. So that tells us that this is not the one I'm used to doing, and I'm used to having one that opens up or down. So this one is going to open side to side. But I don't know if it opens left or right yet until I get that p-value identified. Notice that we don't have any parentheses here. So what does that tell us about our vertex? Right, it's going to be at the origin, just like the center, right? When we didn't see the parentheses, we knew the center was at the origin. So when we don't see the parentheses, we know our vertex is at the origin. I want to get this in the form, though, where y squared equals 4px. So basically, I just have to factor out a 4. I need to change that -12 into 4 times something, and then I can identify my p. So y squared equals 4 times -3x. So we know then that our p-value is -3. Since p is negative, that means that our parabola is going to be opening to the left. Question so far? All right, let's graph. I know my vertex is right on the origin. I know that my directrix and my focus are going to be absolute value of p units away from our parabola. Now, don't do this crappy drawing that I'm about to do. We know that this is opening this way. And I remember that the directrix is always behind the parabola. So that tells me that my directrix has to be over here, and we're going 3 units. So there we are. There's our directrix. And then that means that my focus is p units from the vertex, but inside the parabola. So my focus is going to have to be right here. All right, now I'm ready to figure out how wide this parabola is so I can draw in a good picture. From our focus, we're going to go 2p in either direction to get the width. So p was 3, so I'm going 6. In either, and now that I have these 3 points, I can draw in my parabola. And there we go. Questions on drawing that in?
Can you explain how you got 6 again, please?
I take my p-value, which is -3, and just multiply it by 2. Because the whole length of this lattice rectum has to be 4p, so I'm just splitting it and going
Oh,
2 up and 2 down.
okay. Thank you.
So are there no asymptotes in with the,
There are no asymptotes in this one. The hyperbola is the only one with the asymptote.
okay,
Again, I drew that directrix as a dashed line because technically it's not actually part of the graph. Only the red is part of the graph, but it's our guideline.
Okay.
So where is our focus located? Count over, -3, 0. And our directrix is a line, so make sure you write it as an equation of a line, and it's a vertical line. So it's going to be x equals a number. And that number is going to be x equals 3. Questions? So I know it's 10:38. Can I do a couple more? Anybody object to that?
Let's do it.
You know, that whole balance of, oh, we took a day off here, but maybe we need to run 10 minutes late another day. All right, so here we're writing the equation of the parabola with a focus of 0, 20 and a directrix of y equals -20. Just like with the hyperbola, I usually start with just a general kind of picture so I can figure out, is it x squared, is it y squared? So I have a directrix at y equals -20. y equals tells me horizontal line. And then my focus is up here. We know the directrix is behind our parabola and the focus is inside the parabola. So our vertex is halfway between. So this tells me that I got a parabola like this. So just based on this, what all can we conclude? Which variable is squared?
The X.
Mm-hmm. We know that the vertex is going to have to be at the origin because it's halfway between our directrix and focus. And what can you tell me about the p-value?
Is it 20?
Well, you don't be so specific. Yes, but don't be so specific. Is it positive or negative is what I'm looking for.
Oh, positive?
It's going to be positive because we're opening up.
Yeah.
If it was down, that would tell us our p-value is negative. And he already specifically told me it was 20, which is correct. All right, so since we're at the origin for our vertex, we know that our equation simplifies to x squared equals 4py. P equals 20, so all we're doing is plugging that in. X squared equals 4 times 20y. X squared equals 80y. There we go. Questions, anybody? All right, let's graph one where our vertex is off the origin. Is this going to be opening up and down or side to side?
Up and down?
Since x is the one that's squared, we're going to be opening up or down. Let's identify our vertex. What's that going to be? Oh, wait, you know what? I might not even do that yet. I might try to get it into the form, right? We want it to be x minus h squared equals 4p times y minus k. So we're almost there. All right, it's just this thing in front of the parentheses should be 4p. I guess it didn't really matter which order we did this in. So this is like the same as 4 times 1. So it tells us that our p-value is 1. All right, I probably would have found the vertex first. And then gone back and did what I just did. All right, what is the vertex?
-2, -1.
Great. And since our p-value ended up being +1, is this going to be opening up or down?
Up.
You got it. Well, since I know that it's going to be opening up, and I know that, and again, that's just a crap drawing there. I kind of just do that for myself so I get my directrix and stuff in the right spot. I know that my directrix is p units behind the parabola. So p is 1. That tells me my directrix has to be here. And my focus is P units inside the parabola, so my focus has to be right there. To get the actual width of my parabola from my focus, I'm going to go 2 P units, in this case, side to side. So 2 to the left, 2 to the right, and now that I have these 3 points, that's all we need to draw in our parabola. There we go. Our focus is located at -2, 0, and our directrix, this time we have a horizontal line, and horizontal lines are always y equals a number. Our directrix, y equals -2. Questions, anybody on the parabola so far? Okay, so didn't mean to do that. Anyways, so on Wednesday, we'll wrap up the parabola. We got one more graph to do where we're gonna have to complete the square to get it into the appropriate form. And then we have several application problems to do because a lot of things are parabolically shaped. Satellite dishes, flashlights, bridges. So we'll do several applications and then we're gonna move on to parametric equations. So that's the plan for Wednesday, and then Friday, man, it's exciting. We start that like first calculus chapter. On Friday, we're gonna start limits, which is really the stuff that it's basically chapter 1 in Calc 1. So,
Woo.
yeah, it's exciting. All right, anybody questions on anything?
Could I speak to you before you leave?
Absolutely. I did get the first set of quizzes graded. Here, I'm gonna stop recording. Hear everything I'm about